I'm Ant Kennedy, CTO at GapSquare. Been running Kubernetes workloads in production for about 2-ish years now at various companies, and I've made a lot of mistakes along the way. So kind of talk you through some of the lessons learned and some of the basics that you can get done, get those out of the way, and make your life a lot easier in the long run. So I guess the main thing we're trying to avoid is this. The world could be burning down around you, production's down, CEO's emailing you, what the hell is going on? You're none the wiser. So there's a few steps you can take to kind of alleviate this problem. Again, makes your life better, but you will be alerted when things start to go wrong. So it's a double-edged sword in that respect. So first thing you should be doing is centralizing your logs. We've all been there where you've kubectl get logs from your pods when things start going wrong, and you end up with something like this. So here we're grabbing the logs from the ingress, and we've just got a massive dump of not necessarily useless information. There's a few nuggets in there, but how do we begin to actually start processing this? Pipe it out to a file and start dealing with it that way, or be a bit more sensible and use a log aggregator such as FluentD. So what FluentD allows us to do is essentially start pulling in logs from various different processes. In our case, we care about the kubelet logs and the Docker logs. And then we'll pipe them out into pretty much anywhere you want. As was mentioned earlier this morning, there's loads of plugins available for this. So in our instance, we're pulling in Docker kubelet logs and we're pushing them out into Oracle Object Storage for long-term access and into Elasticsearch so we can start exploiting them straight away. The way it's deployed on Kubernetes is we have a FluentD daemon running on each node. That's then sat there mounting a volume from the Kubernetes nodes where it can then start scraping the logs and pushing them out to the various endpoints we configured. So with this in place, we then have all our logs in the database, searchable, viewable, and start doing some interesting things. So in our production workloads, we're not actually running any PHP at all. We look through the same ingress logs we had earlier. There's a lot of scanning going on, trying to inject various PHP scripts. So from a security perspective, this is fantastic. We can see who's potentially probing us and scanning us, and then we can start trying to mitigate those issues. This is, however, not the be-all and end-all. So we've got the logs in place, that's great. We can go back, we can assist in our post-mortems, we can understand what went wrong, if it went wrong. FluentD has a Helm chart available. There's there for Elasticsearch and Kibana. Get those set up, and you can pretty much be up and running within half an hour. Use Kubernetes labels on your workloads, so you can then search over these labels and gather logs that way. It makes life much easier. Also, if you happen to be using JSON logging as your standard format, you can then delve into these complex data structures and start to get a lot more meaningful information rather than doing Lucene text queries over the data. And if you're not using them yet, use correlation IDs. As soon as a request hits your infrastructure, assign a correlation ID, pass that correlation ID around everywhere and log it out. This will make tracing erroneous requests through the system much easier later on. So I jumped ahead of myself earlier, but it's not the be-all and end-all. Got logs. What about alerting? So it's great for post-mortems, but you want to know when things start going wrong and potentially even before they start going wrong. So hopefully everybody's using some form of uptime monitoring. So services like Statuscake, Pingdom, etc. They'll probe your services, you give it a response code that you're expecting, and if it fails, it fails. You can get an alert, Slack, email, etc. So that's great for all of your public-facing endpoints, but what about your internal services? So this is where tools such as Prometheus allow us to start scraping our internal pods, the kubelets, for metrics so we can understand how the system as a whole is going on. So a couple of components to Prometheus. There's a server which will essentially scrape all your logs, pull them into you. The alert manager, which as you might have guessed by the name, will actually manage your alerts for you. So you can silence them, push them out to Slack, email, etc. And then the push gateway is there particularly for jobs. So things that you aren't long running, that you wouldn't necessarily be able to expect to scrape all the time. So this provides an endpoint for Prometheus to scrape. You can push your logs, say, at the end of a Kubernetes job to say how well it went. So once we started collecting all these metrics from Prometheus, we can then start visualizing in something like Grafana. So here we've got a couple of dashboards from our production instance. So we're monitoring the state of our Kubernetes cluster. So we want to know, are all our nodes running? If they're not all running, something bad's probably gone wrong. And we're also monitoring the CPU, memory usage, and the API requests actually being made into our system. So Prometheus provides 4 types of metrics that we're able to collect. So a counter, which counts, a gauge, which goes up and down, a histogram and summary, which both allow aggregation of these metrics, either by percentile or bucketing. We can also start to do cool stuff around looking at the rate. So here we've got the bytes over 5 minutes that the service is receiving, and you can potentially even take it one step further and start using linear prediction. So let's say disk space is getting full on your node. Let's predict, see what happens over the next 48 hours. If it looks like it's going to get 90% full, send an alert. So we've got great, we can see what's going on, and we mentioned that we have alerts firing. So the other day in production, something very bad happened. One of our nodes disappeared. Okay, that's great. So we got our alerts from Stacecake saying production's down, fix it. But we were able to actually immediately see that something worse had gone wrong inside Kubernetes. So CO advisor's down, and then an alert for the node being down. This gave us much more a targeted response to what we need to do, rather than us diving in and starting to delve down into logs of our services. That's normally the problem. It's us that's done something wrong rather than Kubernetes. We know where we can start mitigating these issues and targeting it. So for all the Brits out there, time for a bit of a Brucey bonus. For everyone out there, if you're not using Helm already to manage your workloads, please start doing it, particularly around your third-party components. So things like Prometheus, Grafana, Elasticsearch, Fluentd, Kibana. There's charts out there, you can get up and running in minutes, and you can configure and customize them where possible. Please also make sure all your Kubernetes configs are under version control. I cannot hesitate to state this enough. If there's more than one of you on the DevOps team, and you're directly modifying live configs, how do you know you're editing the latest? Or particularly if you're straight applying files over the top. And what about secrets, you asked? There's a project out there called KubeSeal, which will use the public key on the master node to actually seal your secrets so they can only be decrypted on that single Kubernetes cluster, which is really great. You've then got everything checked in and good to go. Use Cert Manager for issuing TLS certificates. So this will, on a generation of a new ingress, will go fetch certificates for you from Let's Encrypt. So you immediately no longer have to worry about managing certificates. And then if you really care about security, run Kubebench against your clusters a couple of times a month at least. So for those who aren't there, the Cloud Internet Security have a bunch of benchmarks available for Kubernetes out there. And this will give you a quick security evaluation in terms of any of the larger holes in your security setup. That's pretty much it from me. Cool. Excellent.